In this video, we are going to see what is the logic behind finding the square root by division method. So why does this particular method work? Before we start to understand, let us take the example, let us have a recap of finding the square root of 5329 by division method. So we make such an arrangement, we write 5329 and then we start grouping the digits. So we make a group of 29 and 53. This should be a group of 2. And then we see 53 comes between 49 and 64, which is 7 square and 8 square. And since 7 square is 49, which is smaller than 53, we write 7 sevens are 49. Then we take the difference and we write a 4. Then we add a 7 to get a 14. Then we bring down the 29 and we write this 14 a little towards the left, leaving some space behind it. Now we need to search a number such a way that after we write it behind 1, 4 and that number, multiply by the same number, we should get 429 or less. So we try with 2, we experiment this with 2, so 142 2s is 284. Then we try it with 3 and 143 3s is 429. So we have got it. So 143 3s is 429. Then we subtract it to get a 0. And when we get a 0, we know that this is a perfect square. So 5329 was a perfect square, is a perfect square of 73. Just to finish this off, we add a 3 to get 146. Now many of you have this question that why does this method work? Why do we add a 7 under the 7? And why do we write this 14 a little towards the left? Why do we leave this space behind it? And why do we get a square root over here itself? And why is this 146 double of 73? So in this video, we are going to try to answer all these questions. But for that, we need to start with this particular example, 5329, whose square root is 73. So this is a table, 0 square is 0, 10 square is 100, all the way till 100 square is 10,000. So on looking at this table, we know that 5223 lies in between 4900 and 6400, these two perfect squares. So taking the square root on both sides, we have all sides in fact, that the square root of 5329 lies between 70 and 80. So the first thing we come to know is it lies in its 70s. So the number could be 71 or 72, etc. Now consider a square, a perfect square, whose area is 5329, this number. We know that the area of a square is side square. Taking square roots on both sides, the side is the square root of area. So that means that if this area is 5329, the length of these sides would be exactly the square root of 5329, and we know it lies between 70 and 80. So what we do is we draw a square whose sides are 70 exactly in this map. So it will fit inside this big square. And we know the area would be 4900. So area of this entire blue square is 5329. The area of this yellow square is 4900. So what we do is, while writing this in the square root method, we write this as 7 sevens are 49. Okay? And the difference of 5329 and 4900 is 429. So the area of this remaining blue part is 429, because this entire area was 5329. We took away the yellow part, which is 4900, and so it turns out to be that the remaining portion is 429. So let us say that this length, the remaining length, is b units. So we draw a rectangle, a pink rectangle, such a way that the length of this rectangle is exactly equal to the length of the side of the square, which is 70, and the breadth is that remaining part of the square, which is b. We draw another rectangle over here. So these two rectangles have area of 70b, and we cover the remaining part of the blue square as it would be b from both sides. So the area of this part is 70b, the area of this pink part is 70b, which is 70 multiplied by b, the unknown b, and the area of this square is b square. So it happens to be that this pink rectangle plus this pink rectangle plus the green square is 429 or a little less than it. If it is not a perfect square, it's less than 429, otherwise it is exactly equal to 429. Why 429? Which is the difference between 5329 and 4900. We factorize the b out, so we write 70 plus b. Outside the bracket we write another b. 70 plus 70 is 140 plus b, and multiplied by b gives 429. So we write this while writing the square root in division method as follows. So we write 7 sevens is 49. So actually what did we do is we actually wrote it as 70 70s are 4900. So we're not writing the two zeros and not writing a zero over here, but 7 plus 7 is 14. So actually this is 7 in the tens place. This 7 is in the tens place. One more digit is going to come over here. So it is actually 70 plus 70, which is 140, which we can see it over here. So since this is 140, we are leaving some space behind it, so that when another digit comes, it would be added to that 140. And that extra digit that is now going to come is that number b. So we try an experiment. So we write b after that 140 something, multiplied with the same b. So 140 plus b multiplied by the same b should give us 429 or a little less. So we tried with 142 twos, we get 284, and then 143 threes gives us 429. So that tells us that b should have a value of 3. So this should be 3. So now we know that b is equal to 3. 140 plus 3 is 143, 143 threes is 429, and we get both the sides equal. If we get it equal, it's a perfect square. So we come to know that this should be 3, so that the total area turns out to be 5329, and the area of this pink part plus this pink part plus the green part should be 429. So 210 plus 210 is 420, plus 9 is 429. So we write it in this way while writing the division method. 143 threes is 429, and we get a remainder of 0, which tells us this is a perfect square. Now we are going to understand the general derivation of why does this method work for any given numbers. So let us take a number, a 2-digit number. The digit in the tens place is a, and the digit in the units place is b. So this number would be 10a plus 1b, which is 10a plus b. But for the sake of convenience, let us write 10a as a in blue color and b as b in red color. So why are we doing this? We are doing this just to tell that a will have a place value 10 times more than b. So b could be in the tens place, then a would be in the hundreds place. If b is in the 1/10th place, then a would be in the units place. But for now, let us consider a to be in the tens place and b under the units place. We know that a plus b the whole squared is equal to a squared plus 2ab plus b squared. So over here, though I may not be writing 10a, this a, since it is written blue color, is actually 10a. And b, since it is written red color, is a unit b, 1b. The geometric interpretation of the same is as follows. So let us say we have a square, a perfect square, whose sides are a plus b, a plus b. So we draw a square whose sides are a, so we get an area of a square, which is this portion. Then we have two pink rectangles whose sides are a and b, so the area is ab, and so is this area ab, so we have 2ab. And then we have a square, a tiny square whose sides are b. So this area is b squared. So a plus b the whole squared is a squared plus 2ab plus b squared. So we write this a squared plus 2ab plus b squared as if we are writing it in the division method. So we first start with a. We know a is a squared. We take the difference, we get a 0. Now we bring the 2ab plus b squared down. Now this 2ab plus b squared has b common. So we take the b out. This becomes 2a plus b multiplied by b. Now we need to know what number should come over here. So we do not know what is b, but we at least know what is a. A is already known to us. So we know that 2a when added to that unknown b and this total taken together when multiplied by the same unknown b will give us this particular thing. So since we require one more a, we have 2a, we add a over here. So a plus a gives a 2a, and that is this 2a. And now we want to find what number should be added over here so that when multiplied with the same number, it should give us 2ab plus b squared. So we keep on experimenting and we finally arrive at a number. So that's b. So 2a plus b multiplied by another b gives us 2ab plus b squared. And then we subtract this to get a 0. Of course, this should get a 0 if it's a perfect square. Otherwise, there will be some residue left. And if there is some remainder leaving behind, it's not a perfect square. So we need to go further and we add another b to get 2a plus 2b. And this 2a plus 2b is always double of a plus b. And we know a square plus 2ab plus b square was the question whose square root was to be determined. And we know the square root of that is a plus b. So this a plus b is the answer. And over here we always get a 2a plus 2b. Let us take another example in which we have a 3-digit number. So let the digit in the hundreds place be a, the tens place be b, and the units place be c. So that number will become 100a plus 10b plus 1c. But in any case, a could be under the thousands place, then b would be under the hundreds place, and c would be under the tens place. But for this particular example, we are going to stick with this. So let us say this 100a be written as a in blue color, 10b be written as b in red color, and c written as c in a green color. There's a formula a plus b plus c the whole square, which is a square plus 2ab, sorry, a square plus b square plus c square plus 2ab plus 2bc plus 2c. And this is the geometric interpretation of it. So this is a plus b plus c, a plus b plus c. So this is a plus b plus c the whole square, which is a square, which is this orange part, plus b square, which is this portion in light green, plus c square, which is this tiny square, plus 2ab, which is this pink plus this pink, plus 2bc, which is this yellow portion and yellow portion, plus 2ca, which is the orange part. Now what we do is, we take this 2ab a little forward, a little in front. So we have a square plus 2ab plus b square. We are just rearranging it so that we can factor out the b. So we write 2a plus b, and in outside the bracket we write another b as we seen in the previous example. And we take this 2ac a little in front, then 2bc, and we write the c square at the very end. So we again take the c as a factor over here, and we write 2a plus 2b plus c, and the c is outside the bracket. So a plus b plus c the whole square can be rewritten as a square plus bracket open 2a plus b, close the bracket b, plus bracket open 2a plus 2b plus c, close the bracket c. So we're going to write this number: a square plus 2ab plus b square plus 2ac plus 2bc plus c square. We start with a. A multiplied by a is a square. We take the difference, we cancel out the a square. Now we bring down the 2ab plus b square. So, like in the previous example, we require a number which is 2a plus that experimental number b, and this entirely multiplying with experimental number b to get 2ab plus b square. So, since we require 2a, we add a to get a 2a. We write a plus b afterwards. We need to find this out. Multiply by the same b to get 2ab plus b square. We take the difference, and then we bring down these numbers: 2ac plus 2bc plus c square. Now we already have 2a plus b at our disposal. Now we know what is a as well as we know what is b, and we need to find this thing: 2ac plus 2bc plus c square, but we do not know what is c. So what do is we factor this out, we take the c out, and we write 2a plus 2b plus c, and c taken out. We already have 2a, so that's not a problem. We only have one b, so we require one more b because b is known to us. We add a b to get 2a plus 2b, but we still do not know what is c, and multiplying with the same number c. So we again do the experiments. We add a c, multiply with the same c to get 2ac plus 2bc plus c square. We find the difference, and if we get a 0, it's a perfect square. If we get a residue, some difference, it's not a perfect square. We need to go on with this method. And finally, we add a c. If it's not a perfect square, it would be helpful to get 2a plus 2b plus 2c, which is exactly double of a plus b plus c. So remember, a is in the hundredths place, while b was in the tens place and c was in the units place. If you understood, do share this video with your friends, with your teachers. Do like this video. Please subscribe to my channel, and thank you for watching.